This is Gemini Control. The count, T-minus 26 minutes and proceeding. At this time, Mission Director Chris Kraft has just completed a status check of his flight controllers, or shortly will in a very few minutes. Everything checking out very well so far. You may have noticed the striping around the spacecraft. This is a slightly different pattern than we've seen in earlier Gemini flights. Those black stripes were added to raise the temperature slightly in that equipment adapter, which houses most of the major systems on board, such as the maneuvering system, fuel, the environmental control system, water boiler, radiator, and other major items that include the batteries. The temperature varies from point to point in the equipment adapter. At the lower end of it, in space, it runs approximately 100 degrees below zero. Meanwhile, the Vice President paid about a 5-minute visit here on the floor, talking with the mission director. He then chatted briefly with astronaut Wally Schirra. He also talked to astronaut Gordon Cooper, the capsule communicator here in the control center for this mission. And he met astronaut Gene Cernan, as well as a number of other flight controllers. He's returned to the viewing area of the control center, from which point we understand he plans to observe the flight. This is Gemini Control.
The tense moments leading up to the first manned Gemini launch. Hello and welcome. This is Michael Annis, and you're listening to episode 58 of the Space Rocket History Podcast. I recommend listening to episode 57 before you listen to this episode. And now, Corned Beef Controversy, Gemini 3 with Gus Grissom and John Young, Part 2. The official designation for the third Gemini flight was Gemini 3. Unofficially, it was the voyage of Molly Brown. During Project Mercury, each pilot had named his own spacecraft. Gordon Cooper had some difficulty selling NASA on Faith 7 for the name of the last spacecraft in the Mercury program, and now Grissom and Young had some difficulty with the name Molly Brown. Grissom had lost his first ship, the Liberty Bell 7, which sank after splashdown when the explosive hatch blew out prematurely. For more on this, listen to episode 27. Molly Brown was the unsinkable heroine of a Broadway stage hit. To Grissom, this seemed like a very logical choice for his second Space Command, but NASA's upper echelons thought the name lacked dignity. When asked to change the name, Grissom replied, "How about the Titanic?" Eventually, NASA grudgingly consented, and the name remained Molly Brown, though only quasi-officially. Later spacecraft were officially referred to by a Roman numeral. Now let's move on to the launch of Gemini 3. During the first 2 days of March 1965, the Office of Manned Spaceflight held a design certification review in Washington. The review board asked for and received formal pledges from the top executives of all major Gemini contractors that their products were ready for manned space flight, barring something unforeseen turning up during what remained of the checkout at Cape Kennedy. A week later, the spacecraft flight readiness review revealed only minor and quickly corrected problems. On March 18th, the launch vehicle passed its final test, and on Saturday morning, March 20th, it passed its flight readiness review. When the Mission Review Board met that afternoon, the only concern they had was the weather. Early Monday morning, the launch vehicle contractors confirmed that GLV-3 was ready to go. At 9 a.m., the Flight Safety Review Board committed the booster to launch. At 6:22 p.m. on March 22nd, Martin's pad crew started loading oxidizer aboard GLV-3, and 5 hours later, all tanks were full. A final countdown began at 2 o'clock Tuesday morning under overcast skies. The astronauts, Grissom and Young, who had reviewed their flight plan and gone to bed around 9 o'clock that night, were awakened shortly before 5 a.m. After steak and eggs, a launch day breakfast tradition inherited from Mercury, they were driven from their Merritt Island quarters to Pad 16, the site of the pre-flight ready room. They arrived about 6 and had their suits on in about 45 minutes. Shortly after 7, a van took them to Pad 19. They mounted the elevator for the 11th level where their spacecraft awaited them. At 7:30, they were inside with the hatches sealed. Because the so far flawless countdown had moved faster than expected, they were about 20 minutes ahead of schedule. Weather was still the big question mark. The skies were still overcast. Grissom and Young had been in the spacecraft less than an hour when the count was halted just 35 minutes before launch, because the first stage oxidizer line had sprung a leak. A handy wrench applied to a poorly seated nut solved the problem, but the count was held for 24 minutes to make certain the leak had stopped. By the time the countdown resumed, the clouds over the Cape had begun to scatter. As with any first launch, there was some tension with the ground crew. Here's an audio clip.
Cape procedures, Carnarvon, Capcom.
Go ahead.
Dutch, if you got somebody down there off the street, you can put on this thing and tell us what goes on when you miss the voice checks and things like that. This $10 silence doesn't do us any good.
I gave you a T-minus 30-minute voice check, Dan, and we're counting. I don't know what more you want me to tell you. I've sent you 10 Twixes.
You got a T-minus 25-minute voice, network voice check by AFD?
No, T-minus 30. I gave you a check when we picked up the count.
Okay.
If you miss the count by 2 minutes, don't get too excited.
No, I'm not excited. Somebody can just say we went on internal power or something like that, but these long, pregnant silences.
I already sent you the message on internal power and static firing.
Okay. This line is leased 24 hours a day at no expense.
Calm down. You'll get acquisition in 50 minutes.
Included in the countdown were static firings of both spacecraft rocket systems. This had been a matter of dispute between the astronauts and the program office. They agreed on plans to fire one ring of the re-entry control system, but not on Ohm's firing. The Gemini project office backed the pre-flight operations division and preferred to fire only the lateral thrusters, but the pilots wanted to fire the aft thrusters too. The matter was settled in May of 1964 when NASA Deputy Director for Gemini, William Snyder, decided both would be fired. Although he knew that the extra time might affect the launch, he believed that it would save time in the long run and would increase the confidence in flying a successful mission. Here's a clip of the thruster check at T-minus 20.
This is Gemini Control. The count, T-minus 20 minutes and counting. At this time, we are standing by for a check of the re-entry control system propulsion rings located about the neck of the spacecraft. Each of the thrusters will be flipped. There was the first flip, about a 20 millisecond first from the B-ring thruster. Each thruster will be taking in sequence around. There are 8 thrusters in each ring. The rings are duplicated, completely redundant, giving us 16 thrusters, which will control the attitude during the re-entry phase of the mission. This is Gemini Control. This is Gemini Control. We are still continuing here to test our thrusters about the spacecraft, the smaller thrusters with 25 pounds thrust each up in the re-entry control section have been tested. We're now working on the thrusters in the equipment and in the retro portion of this spacecraft. Each of these thrusters has a capacity of 100 pounds thrust. Each of the aft firing thrusters, that is, and we have 2 thrusters which fire in a forward direction. They have a capacity of 85 pounds thrust. Spacecraft test conductor George Page is working with astronaut Gus Grissom in these tests, giving him a countdown list or a checklist, as it were, to ensure that the right switches are in the right positions before actuating these thrusters. The count at this time, T-minus 12 minutes and proceeding. This is Gemini Control.
At T-minus 9 minutes, voice checks of the global network.
Hawaii Capcom, AFD voice check.
Hawaii Capcom, loud and clear. Our status is green.
Roger, loud and clear. RKV Capcom, AFD voice check.
AFD RKV Capcom, our status is green. We are loud and clear.
Roger, loud and clear. Guaymas Capcom, AFD voice check.
This is Guaymas Capcom, our status is green. We are loud and clear.
Roger. Houston AFD. AFD, how do you read?
Roger, loud and clear. We're green.
Okay, Joe, we're go here.
Roger, good luck.
With everything at go, it was time to light the candle. We join the countdown at T-minus 30 seconds.
T-minus 30 seconds. Recorders have gone to fast speed.
20 seconds.
20 seconds. 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, 0. Ignition. And we have a liftoff.
Liftoff 142400 142400 liftoff.
There's a roll program. Roger, roll.
Flight 10 seconds.
Rising very nicely.
Roll's completed.
Cabin pressure
Roger, roll
turning.
complete. There goes the pitch. Roger, pitch. You're on your way, Molly Brown. Yeah, man. Last 50 seconds. Roger, and the mode 2 delay. Roger. And cabin pressure, hold at 6-0.
They count 60 seconds. T plus 60 seconds. That booster's flying at a speed of 658 miles an hour. The crew is pulling approximately 2 Gs. They are now going through the area of max Q.
At 9:24 a.m. Tuesday morning, March 23, 1965, the engines of GLV-3 burst into life, and with a "You're on your way, Molly Brown" from Capcom, which was Gordon Cooper, the third flight of Gemini, the first manned flight, began. Molly Brown lifted off so smoothly that neither Grissom nor Young felt anything. Their real cues were seeing the mission clock on the instrument panel start running and hearing Cooper announce it from mission control. There was less noise than they had heard on the simulator in Dallas. When the first stage engine cut out, 2.5 minutes later, acceleration plunged from 6 gravities to 1 gravity. The second stage engine ignited, bathing the spacecraft in a flash of orange-yellow light. John Young was a little disconcerted for a moment until he realized that this was a normal product of the fire-in-the-hole staging, that is, second stage ignition before separation from the first stage. The launch vehicle had slightly exceeded its predicted thrust, but a warning from Cooper prepared the pilots for the larger-than-expected pitch-down when the second stage took over the steering. Young, who had never been in space before, was entranced by his view of Earth's horizon and the sense of rapid motion as the second stage thrust built up. Here's the clip.
We're 2 minutes into the flight. The velocity of the vehicle right now is approaching 3,000 miles an hour. The G-force is building to 3.3 Gs. The crew reports they're in fine shape, and everything looks green here in the control center.
Update received. Roger, update.
We're coming up on staging or booster engine cutoff.
Roger, stage.
We have a staging report. We can confirm staging.
Okay, thrust looks good from here.
We have second stage ignition and second stage thrust looks fine.
Show full scale round to there. Okay, we're starting the steering.
At T plus 4 minutes, everything is go.
Just told Grissom that he's looking mighty good, and Gus gave him a very reassuring laugh. A very calm pilot in command of that spacecraft.
Roger, Molly Brown, your go from here. Roger, Molly Brown, let's go. Roger.
4 minutes and 35 seconds into the mission. The velocity of the spacecraft now approaching 12,000 miles an hour. The G-forces in the range of approximately 3.5 Gs.
Steering right
Flight
down
dynamics
the line.
officer reports excellent steering on this vehicle. We remain in the primary guidance phase all the way.
5.5 minutes after launch, the second stage engine shut down. The pyrotechnic explosions that severed the spacecraft from the launch vehicle sounded like howitzers to Young. Grissom fired the aft thrusters to kick the spacecraft into orbit, but he lost track of the time and fired too long, ending up with an incremental velocity indicator showing 2, which meant there was a slight overspeed. But he wound up with an orbit of 122 by 175 kilometers, very close to the intended 122 by 182 kilometers. Gemini 3 was off to a good start. Here's the second engine cutoff, or SECO, clip.
Seconds from SECO, or sustainer engine second stage cutoff.
Roger, showing good one there. Going to Bermuda.
Standing by for confirmation of SECO.
Roger, you are go, Molly Brown.
Has asked Gordon Cooper to tell Gus Grissom that he is go.
Roger.
And Molly Brown reports it's very happy about that go.
About 20 minutes into the first orbit, just after Molly Brown passed beyond the range of the Mid-Atlantic Canary Island tracking station, the oxygen pressure gauge in the environmental control system reported an abrupt drop. Young was assigned to watch this gauge. He assumed that something was wrong with the system, but a quick glance showed odd readings on several other meters and suggested that the real trouble might be in the instrument power supply. Young switched from the primary to the secondary electrical converter to power the dials, and the problem vanished. The whole episode, from Young's first notice of the anomalous reading to his shift from primary to secondary power, took only 45 seconds, a very clear payoff from all that time spent in the simulator. At 18 minutes 41 seconds, Grissom reported that the spacecraft was in a continuous, very slight left yaw. He believed it was a stuck thruster, but it was eventually traced to a venting water boiler. The rest of the first orbit was spent checking the spacecraft. During the second orbit, the astronauts conducted the experiments that I mentioned in the previous episode. Grissom's attempt to run the cell growth experiment was a failure. Perhaps, as he remarked later, because he had, quote, too much adrenaline pumping, end quote, and twisted the handle too hard. Whatever the reason, the handle broke while the experiment was running. The radiation experiment gave Young some trouble, but he managed to complete his task. Results were suggestive but inconclusive. Exposed to nearly identical doses of radiation, the in-flight blood samples showed more damage than the control samples on the ground. While the effect was small, it did point to interaction between radiation and some aspects of spaceflight, though just which aspect and how it acted could not be answered. Both Grissom and Young believed that most of the trouble with the experiments stemmed from the differences between the packages they flew with and those that they had been trained on. But they also admitted that they were not quite as fascinated by sea urchins as by the chance to carry out some real firsts in spaceflight. At T plus 1 hour 52 minutes, the most controversial event of the flight began. I'm going to read from the transcript of the capsule voice recorder. Grissom: "What is it?" Young: "Corned beef sandwich." Grissom: "Where did it come from?" Young: "I brought it with me. Let's see how it tastes. Smells, doesn't it?" Grissom: "Yes, it's breaking up. I'm going to stick it in my pocket." Young: "Is it? It was a thought anyway." Grissom: "Yep." Young: "Not a very good one." Grissom: "Pretty good, though, if it would just hold together." Young: "Want some chicken leg?" Grissom: "No, you can handle that." The whole incident took less than 1 minute. A firestorm blew up when the press got wind of Grissom's having eaten part of a corned beef sandwich during the flight. Sherrall had brought it at Woofy's on North Atlantic Avenue in Cocoa Beach and given it to Young, who smuggled it on board the spacecraft. When it was time for the crew to eat the space food they carried, Young brought out the sandwich and handed it to Grissom, who ate only a few bites, as he wanted no crumbs floating around the cabin. When the news got to Congress, the lawmakers were upset. It was never made clear to either the legislators or the press that the official food was only there for evaluation of its taste, convenience, and reconstitution properties, and had nothing to do with any scientific or medical objectives of the mission. No one expected to learn very much about the effects of space food on so short a flight. The fracas did, however, produce some new and more stringent rules about what the astronauts might take with them on future missions. This is how Gus Grissom described it. Quote, "After the flight, our superiors at NASA let us know in no uncertain terms that non-man-rated corned beef sandwiches were out for future missions. But John's deadpan offer of this strictly non-regulated goodie remains one of the highlights of the flight for me." End quote. Here's a clip on Wally Sherrall's take of the controversy.
And that was prepared the night before the flight, and then I took out the crew quarters and kept it in the refrigerator, gave it to John that evening, and we kept it chilled so there was no chance of it spoiling. And we've been eating these, I might add, regularly for months before this flight, and there were no dietetic problems that we could detect. So it was rather facetious the way the world made a big argument about it and embarrassed John Young and attempted to embarrass me too, I suppose. But after all, just because we hadn't put on a spacesuit doesn't mean we have to stop eating normal food. We'd never last if we didn't have these little breaks in the routine.
And here's a clip from John Young.
No, it really wasn't for fun. It was for to take a guy's mind off his work when he was really busy and in some kind of a difficult situation. That's what I used it for, and that's what it was for.
Moving on from the corned beef controversy, the Gemini 3 crew did manage to chalk up at least one historic first, and that was by maneuvering in orbit. The first ohms burn came an hour and a half after launch and lasted a carefully timed 75 seconds, cutting spacecraft speed by 15 meters per second and dropping it into a nearly circular orbit. 45 minutes later, during the second revolution, Grissom fired the system again, this time to test the ship's translational capability and shift the plane of its orbit by 0.02 degrees. The last burn came during the third orbit. Grissom completed the fail-safe plan with a 2.5-minute burn that dropped the spacecraft's perigee to 72 kilometers. This maneuver ensured re-entry even if the retro rockets failed to work, so there was no possibility of a marooned scenario. As the 3-orbit mission neared its close, Grissom and Young ran through the retro-fire checklist. With everything ready, the pilot fired the pyrotechnics that separated the adapter from the reentry module, giving the two astronauts their biggest jolt so far. He then armed the automatic retro fire switch. One after the other, the 4 rockets exploded into life and burned themselves out. Another set of pyrotechnics cut loose the expended package as Molly Brown arced back toward the planet after a 4.5-hour flight. Reentry produced some surprises. At the outset, it matched the simulations both men had been through in training, even to the color and pattern of the plasma sheath that surrounded the spacecraft. After the plasma had formed and communications had blacked out, Young threw the switch to start the reentry communications equipment. The results were encouraging. At high rates of water flow, both UHF and C-band signals from the spacecraft were picked up by ground stations, so it was possible to communicate during the plasma stage of reentry. But then another problem. Molly Brown seemed to be off course. The initial computer readings showed that she would miss her planned landing point by more than 69 kilometers, and Grissom's best efforts to reduce that gap were fruitless. Theoretically, the Gemini spacecraft had enough lift to be piloted to a relatively precise landing, but its real lift fell far short of what had been predicted from wind tunnel tests. As a result, Gemini 3 was about 84 kilometers short of the intended splashdown point. Before they touched down, however, the astronauts suffered another jolt when the spacecraft assumed its landing attitude. After the main parachute deployed, the spacecraft hung from it vertically, with its nose suspended at a single point. Before landing, throwing a cabin switch shifted the spacecraft to a 2-point suspension, with its front end forward and 35 degrees above the horizon. When Grissom hit the landing attitude switch, Molly Brown literally dropped into place, pitching both men into the windshield, breaking Grissom's faceplate and scratching Young's. Due to this accident, future Gemini, Apollo, and Space Shuttle spacesuits used a polycarbonate plastic face shield. The jolt when they hit the water a few minutes later was mild by comparison. Although Gemini was designed to float, all Grissom saw out his window was water. He realized that the still attached parachute was being dragged by the wind, tugging the nose of the spacecraft down. With memories of his ill-fated Liberty Bell 7 momentarily staying his hand, Grissom released the chute and Molly Brown bobbed to the surface, having shown herself fully watertight. The mission plan called for the crew to remain on board until the spacecraft was picked up. A short wait if the recovery ship, the aircraft carrier Intrepid, was only about 8 kilometers away, as Grissom and Young had last heard before they splashed down. When they learned that the real distance was closer to 110 kilometers, Grissom asked for a helicopter to pick them up and take them to the carrier. Still remembering Liberty Bell 7, however, Grissom refused to crack a hatch until Navy swimmers had attached a flotation collar to Molly Brown. This spacecraft was not going to sink, but the crew endured a long 30 minutes as the sealed spacecraft grew hotter inside while it was pitched and tossed on the long Atlantic swells. Heat and motion took their toll on Grissom, although Young managed to keep his breakfast down. Once the collar was in place and a swimmer opened a hatch, the two men lost no time in getting out and putting on the horse collar hoist that lifted them to the helicopter. Medical examinations and debriefings began as soon as the two astronauts were in the helicopter and went on for several days. A brief stir ensued when Grissom and Young had little to say to scientists about their observations, mainly astronomical, while in orbit. Other questions were raised about the failure of the cell growth experiment, but most of the fault could be ascribed to a poorly designed package that was installed in the spacecraft barely a week before flight. A matter of too little, too late. In any case, the brief mission had centered on engineering evaluation of the spacecraft, with a full schedule that left little time for extra work. In total, the Gemini 3 mission was supported by 10,185 personnel, 126 aircraft, and 27 ships. In conclusion, the mission's primary goal was to test the new maneuverable Gemini spacecraft. In space, the crew fired thrusters to change the shape of their orbit, shift their orbital plane slightly, and drop to a lower altitude. Other firsts were achieved on Gemini 3. 2 people flew aboard an American spacecraft, and the first manned re-entry where the spacecraft was able to produce lift to change its touchdown point. Despite its minor problems, Gemini 3 was a complete success as far as its major objectives were concerned. There could be no doubt that Gemini was ready for its role in the manned spaceflight program. The time of testing was over. Thanks for listening to this archive episode of the Space Rocket History Podcast. If you are financially able, please support the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange Donate button or the Patreon link. Thanks.